NASA's Juno just captured something strange on Jupiter, something scientists never expected. The planet's legendary Great Red Spot is shrinking, its violent storms are shifting, and bizarre, never-before-seen cyclones are swirling at its poles. What is happening to the solar system's largest planet? Is Jupiter undergoing a transformation right before our eyes? Buckle up, because Juno's latest discovery might change everything we thought we knew about this gas giant. For centuries, scientists have stared at Jupiter's storms, especially that massive Great Red Spot, wondering what's really going on beneath all that chaos. But until now, everything under those thick, fast-moving clouds was hidden. Juno has changed that. By getting closer to Jupiter than any spacecraft before, it has given us brand new images and data, revealing things never imagined. But Juno's latest findings reveal something so bizarre that scientists are questioning everything, and the biggest shock is yet to come. Juno's latest snapshots of Jupiter are jaw-dropping. The poles are covered in swirling cyclones, creating stunning patterns that look almost too wild to be real. The planet's auroras, huge glowing light shows sweeping over the poles, are completely invisible to the human eye but dazzling in ultraviolet light. These aren't just pretty pictures. They hold the keys to understanding what's happening deep inside Jupiter. One of the biggest questions scientists have had for years is about Jupiter's powerful magnetic field. It's incredibly strong, over 20,000 times more powerful than Earth's. This magnetic force controls Jupiter's storms, helps shape its radiation belts, and even influences its most volcanic moon, Io. The connection between all these things is something scientists are still piecing together, but what's clear is that Jupiter is a giant, chaotic, and incredibly energetic system. Jupiter's Great Red Spot is one of its most recognizable features. This gigantic storm has been raging for over 350 years. But something strange is happening. Juno's data shows that it's actually shrinking. It's still enormous, big enough to swallow multiple Earths, but it's slowly getting smaller. Beyond the Great Red Spot, Juno has spotted new types of storms, like bizarre thread-like cloud patterns that stretch across the planet. These storms aren't like anything observed before, and they're giving scientists plenty to puzzle over. Jupiter's atmosphere is nothing like Earth's. It's a world of non-stop extreme weather filled with powerful winds and giant storms. One of the strangest features Juno has uncovered is something called dark ovals. These stormy spots were first seen in ultraviolet images decades ago, but scientists had no idea what caused them. Now Juno has figured out their secret. These dark ovals are actually formed by magnetic tornadoes, gigantic swirling vortexes created when Jupiter's intense magnetic field interacts with charged particles coming from Io's volcanic eruptions. The result is a mind-blowing display of storm systems unlike anything on Earth. At Jupiter's poles, these storms show up again and again. At the southern pole, they appear 75% of the time. But unlike tornadoes on Earth, which form from changes in temperature and pressure, Jupiter's storms are driven by pure electromagnetic energy. Each one is so massive that Earth could easily fit inside. The material swirling in these storms is up to 50 times denser than the surrounding atmosphere, meaning there's a lot of activity happening deep below the surface. Jupiter doesn't have a solid surface like Earth. Instead, it transitions from gas to liquid as you go deeper. The planet is mostly made of hydrogen and helium, the same elements that fuel the Sun. But here's the wild part. As you travel thousands of miles into Jupiter's depths, hydrogen starts behaving like a liquid instead of a gas. Keep going, and it becomes metallic hydrogen, something so exotic and rare that it only exists under the insane pressures found inside gas giants. This metallic hydrogen is crucial. It's what generates Jupiter's magnetic field, making it the most powerful one in the solar system. Beneath this metallic hydrogen layer, things get even more mysterious. Scientists have long believed that Jupiter has a dense core, But Juno's data suggests that it might not be a solid chunk at all. Instead, it could be a fuzzy, partially dissolved region where rock, ice and gas are mixed together. The conditions at Jupiter's core are extreme, temperatures hotter than the surface of the Sun, and pressures that are millions of times stronger than Earth's atmosphere. No spacecraft could ever survive down there, so everything known comes from indirect measurements and models. Jupiter isn't just a massive planet, it also plays an important role in our solar system. Its huge gravity acts like a cosmic shield, pulling in or deflecting asteroids and comets that might otherwise crash into Earth. This has likely helped protect our planet from destructive impacts over billions of years. At the same time, Jupiter's gravity has captured an incredible collection of moons, 95 confirmed so far. One of the most fascinating moons is Amalthea. Unlike the smooth, round moons we're used to, Amalthea is shaped more like a potato, thanks to its small size. Juno recently snapped new images of this odd little moon, revealing its cratered, rugged surface. Because it orbits so close to Jupiter, Amalthea gets bombarded by radiation constantly. But this tiny moon actually plays a role in Jupiter's faint ring system. Bits of debris knocked off its surface contribute to the planet's delicate, ghostly rings. Jupiter's moons aren't just floating rocks. Some of them may actually hold secrets about life beyond Earth. Europa, for example, has a hidden ocean beneath its icy shell. Scientists think this ocean contains more liquid water than all of Earth's oceans combined. If there's anywhere in the solar system where life might exist beyond Earth, Europa is a prime candidate. That's why NASA is sending the Europa Clipper spacecraft, which will start studying the moon up close in the next decade. Juno's mission is far from over. Every new piece of data adds to our understanding of Jupiter, its storms, its deep interior, and its fascinating moons. As exploration continues, one thing is clear: Jupiter is more than just a gas giant. It's a dynamic, powerful world that holds the keys to understanding how planets form, how weather works on extreme worlds, and maybe even where life could exist beyond Earth. Thanks to Juno, the biggest secrets of this giant planet are finally being revealed. Before Earth even existed, something massive was already shaping the solar system. Imagine the biggest, baddest planet in our solar system, holding on to secrets older than time itself. That's right, Jupiter, the gas giant that may have shaped our entire solar system as we know it. NASA's Juno mission has been diving deep into Jupiter's mysteries, giving us a front-row seat to some of the wildest space discoveries ever. Jupiter isn't just another planet, it's a colossus, a swirling ball of gas that could fit over 1,000 Earths inside it. This behemoth has an overwhelming gravitational pull, sucking in asteroids, comets, and other space debris. Scientists believe that without Jupiter acting like a cosmic vacuum cleaner, Earth might have been battered by space rocks far more frequently. But this massive planet is more than just a shield. It might have had a direct hand in shaping our entire solar system. Rewinding billions of years, the solar system was nothing but a cloud of gas and dust, slowly spinning around a newborn sun. As these materials collided and clumped together, planets started forming. But in that chaotic time, Jupiter may have played the role of a cosmic wrecking ball. Some scientists think that before Earth, Venus and Mercury, other planets may have existed. If that's true, Jupiter's immense gravity could have flung them into the Sun or out of the solar system entirely, clearing the way for the planets we know today. Jupiter's influence doesn't stop there. The planet might not have been born in its current position. Some researchers suggest that it formed much farther from the Sun, possibly 4 times farther than where it is now. This idea, known as the Grand Tack hypothesis, suggests that Jupiter moved inward, shaping everything in its path. As it journeyed closer to the Sun, it disrupted the asteroid belt, altered the orbits of other planets, and even limited Mars' growth. Computer simulations suggest that without Jupiter's movements, Mars could have been a much larger planet, possibly even Earth-sized. One of Jupiter's most famous features, the Great Red Spot, has been swirling for at least 3 centuries. This gigantic storm is a churning, raging vortex with winds surpassing 300 miles per hour. But the strange thing is, it's shrinking. In the 19th century, it was estimated to be over 25,000 miles wide, big enough to swallow 3 Earths. Now it's roughly the size of a single Earth, and scientists are puzzled as to why. Some believe changes in Jupiter's atmosphere are weakening the storm, but no one knows for sure. The color of the Great Red Spot is another mystery. Some researchers think it has to do with ammonia in Jupiter's clouds reacting with ultraviolet light from the sun. This reaction could produce the deep red hues that make the storm stand out. What's even more fascinating is that the storm's color might be linked to its intensity. The redder it gets, the stronger the winds become. But even with these insights, the true nature of Jupiter's atmosphere remains one of the biggest questions in planetary science. Jupiter's atmosphere is an ever-changing, turbulent place. It's not just hydrogen and helium. There are also traces of heavier elements like nitrogen, argon and xenon. The problem is, these elements typically form in extremely cold environments, much colder than Jupiter's current location. This suggests that Jupiter may have originated in the frigid outer reaches of the solar system before migrating inward. If true, this would mean Jupiter isn't just a product of our solar system's inner workings. It could have brought material from deep space with it, influencing the planets that formed in its wake. Understanding how gas giants like Jupiter form is key to understanding planetary systems beyond our own. When a star is born, it's surrounded by a protoplanetary disk, a swirling mass of gas and dust. Within this disk, tiny particles collide and stick together, gradually growing into larger objects. Over millions of years, some of these objects become planets. Gas giants like Jupiter form far from their star, where there's more gas available. But they still need a solid core to attract and hold on to that gas. Some scientists believe Jupiter built its core by capturing small, icy pebbles from the outer solar system, while others think it may have started as a massive rocky planet before pulling in the surrounding gas. If Jupiter did migrate from the outer solar system, it wouldn't have done so without consequences. As it moved, its immense gravity would have pushed and pulled everything around it. This could explain why the asteroid belt is filled with such a strange mix of objects. Some asteroids are rich in metals, while others are more like comets, full of ice and volatile compounds. This diversity hints that the belt was disrupted by something powerful, possibly Jupiter's ancient migration. There's even evidence that Jupiter's movements helped create some of the most intriguing objects in the solar system, including the Trojans, 2 massive groups of asteroids that travel along Jupiter's orbit. The leading group, which moves ahead of Jupiter, is nearly twice as large as the trailing group. Scientists believe this imbalance is a direct result of Jupiter's early movements through the solar system, pulling more asteroids into its gravitational grip as it settled into its current position. NASA's Juno spacecraft has been a game-changer in unlocking Jupiter's secrets. Since arriving in 2016, Juno has been orbiting the planet, collecting data on its atmosphere, gravity and magnetic field. It has captured stunning images of swirling clouds and massive cyclones at Jupiter's poles. These storms, unlike anything seen before, appear to be arranged in geometric patterns, defying simple explanations. One of Juno's most surprising discoveries is that Jupiter's core might not be solid at all. Instead, it could be a fuzzy, diffuse mixture of heavy elements spread throughout the planet's interior. This challenges traditional ideas about how gas giants form and suggests that Jupiter's early history was more chaotic than scientists previously thought. Juno has also helped scientists get a better understanding of Jupiter's powerful magnetic field. Unlike Earth's magnetic field, which is relatively uniform, Jupiter's is lopsided and constantly changing. One region, nicknamed the Great Blue Spot, is an area of intense magnetic activity that appears to be shifting over time. Scientists suspect that deep within Jupiter, metallic hydrogen, a form of hydrogen that behaves like a liquid metal, generates these strange magnetic patterns. Jupiter didn't just shape the planets, it may have stopped some from ever forming. Even with all these discoveries, there's still so much to learn. Juno's mission has been extended, allowing scientists more time to study the planet and its moons. One of its key targets is Europa, an icy moon believed to have a vast ocean beneath its frozen surface. This ocean could harbor conditions suitable for life, making Europa one of the most intriguing places in the solar system. Juno's close flybys of Europa could provide crucial data for future missions that aim to explore this alien world in greater detail. Jupiter's influence reaches far beyond its immediate surroundings. Without it, the solar system might look completely different. Its gravitational forces shape the orbits of other planets, control the movement of asteroids, and even affect the behavior of comets. By studying Jupiter, scientists aren't just learning about a single planet. They're uncovering the history of our entire solar system. NASA's Juno mission has given us an unprecedented look at Jupiter's mysteries. Each new discovery reshapes our understanding of this giant planet and its role in shaping the solar system. From its origins to its storms, from its migration to its moons, Jupiter remains one of the most fascinating and influential planets ever studied. And with every new piece of data, the story of Jupiter and our place in the cosmos continues to unfold. Jupiter has always been a troublemaker in the solar system. Imagine it as the biggest, baddest planet around, throwing its weight and completely changing everything. One of the most shocking things about Jupiter is how it may have interfered with Mars' growth. When the planets were forming billions of years ago, Mars had the chance to be as large as Earth. However, that did not happen. Why? Jupiter probably stole the materials Mars needed or hurled them elsewhere, like towards Venus or Earth. Today, Mars is only about half the size of Earth, and Jupiter's involvement could be the reason. But Jupiter's interference did not end there. It also seems to have prevented another planet from forming between itself and Mars. Instead of a planet, there is an entire belt of rocks and debris in that space. This asteroid belt is about 140 million miles wide and is filled with small asteroids, along with some giant ones like Ceres, a dwarf planet. If Jupiter had not been around, perhaps all that space debris would have combined into a brand new planet. But with Jupiter's immense gravity constantly pulling on these bits and pieces, the formation of a planet never happened. Now here's something even more dramatic. Jupiter might have completely wiped out the first planets that ever formed in our solar system. Some astronomers believe that billions of years ago, before Mercury, Venus, Earth, and Mars took shape, there were other planets orbiting close to the Sun. But then Jupiter moved closer to the Sun and later drifted back outward, disrupting everything in its path. Its gravitational pull may have sent those early planets crashing into each other, breaking them apart into pieces. If this theory is correct, the only reason Earth exists today is because Jupiter cleared the way for it. Jupiter's actions might seem reckless, but they might have also helped create the conditions necessary for life on Earth. One of the greatest mysteries in science is how Earth got all of its water. When Earth first formed, it was scorching hot, too hot for liquid water to stick around. However, today about 70% of our planet is covered in oceans. Where did all this water come from? Scientists think it might have come from icy asteroids, and Jupiter could have been the one to fling those asteroids toward Earth, delivering water and possibly even the essential building blocks of life, such as amino acids. Without Jupiter's influence, Earth might have been a dry, lifeless wasteland. Jupiter is not just a cosmic troublemaker, it also acts as a massive shield. Its powerful gravity can attract comets and asteroids that might otherwise pose a threat to Earth. A famous example of this happened in the year 1994, when a massive comet named Shoemaker-Levy 9 crashed into Jupiter instead of heading toward Earth. If that comet had struck Earth, the results would have been catastrophic. However, Jupiter took the hit, possibly preventing a global disaster. On the flip side, Jupiter's gravity can also shake things up and send dangerous asteroids toward our planet. While it sometimes protects us, it also has the potential to put Earth in harm's way. Jupiter's influence extends beyond protecting Earth from space debris. It also affects Earth's orbit in a subtle but significant way. Normally, Earth follows a nearly circular orbit around the Sun. However, Jupiter's gravity can stretch Earth's orbit into a slightly oval shape. This change in shape brings major climate shifts. Summers get hotter, winters become harsher. This cycle happens about every 45,000 years, and Earth is currently experiencing one of these shifts. Even though there is still so much to uncover about Jupiter, one fact is certain. Our solar system would be completely different without it. If Jupiter had never existed, Earth might not be here, and life as we know it may have never emerged. Scientists continue to study Jupiter, aiming to unravel its many mysteries. NASA has even launched a spacecraft named Lucy to investigate asteroids linked to Jupiter. As research progresses, new discoveries will reveal even more about how this colossal planet shaped our solar system and ultimately our own world. What if Jupiter's influence is actually delaying Earth's evolution rather than protecting it? Could life have thrived even more without it? Share your thoughts in the comments, like and subscribe.